Introduction to Factoring. First, let's investigate some of the vocabulary we'll be using over the next few lessons. First off, a factor is something that is multiplied. So things that are factored are things like 3x and times 2x. So those things are multiplied. A term is something that is added or subtracted. Remember that terms are separated by plus or minus signs. So here we would have something like 3x plus 2 or 5x minus 7. So this is a term and this is a term. So factoring, since factors are things that are multiplied, factoring is the process of making terms into factors. So this is what we'll be doing over the next few lessons. For example, we'll start out with a polynomial like this one, and we'll end up as it's factored. In other words, this is the result of multiplying those two binomials. Now we're kind of unmultiplying those factors. Now when we're factoring, we can simply check the work by multiplying the factors back, and of course collecting any like terms that we might have. For example, here, if I found out my factors were 2x plus 1 and x minus 3, I could check that simply by FOILing. 2x squared minus 6x plus 1x minus 3, and that gives me a 2x squared minus 5x minus 3. I came up with the same thing that I started with, so it must be that those factors are correct. The first thing that we'll work with is the greatest common factor of a polynomial, and that's the common factor with the greatest degree and the largest coefficient that you could take out of a polynomial. It may seem like it's something simple, which it is, but it's also very important that we always take out the greatest common factor before we try any other factoring techniques. Let's identify the greatest common factor here, and then we'll factor the expression. So first, my greatest common factor for the coefficients, the greatest number that would divide both of those would be 3. And for the variables, the greatest factor that could come out of both of those would be an x. So my greatest common factor is 3x. Now we want to write this as factored form, 3x times something. What kind of binomial was multiplied by 3x to get 3x squared plus 9x? Remember that factoring is the same as unmultiplying, or we could divide this to find out what this binomial is. So let's go ahead and divide. 3x squared divided by 3x. So we're thinking over here 3x squared divided by 3x. The 3 cancels completely. X cancels one of those, so we simply have an x left. Now if we hit multiply back, x times 3x is 3x squared. What is our next term? 9x divided by 3x. So over here we're thinking 9x divided by 3x. 3 goes into 9 3 times, and the x completely cancels, so we have just a 3 here. And of course it's a positive 3. Now to check this, we take the factors that we came up with and multiply them back out. So 3x times x is 3x squared, and 3x times 3 is 9x. I do indeed have the polynomial I started with, so this is the way that my polynomial factors. Now I have terms here And here I have factors because it's this times this. So I've turned something that looks like terms into things that look like factors. What is the greatest common factor here? Well, we're looking at the coefficients 6, 3, and 9. What's the largest number that we could divide each of those? We have a 3 then. And my variables, z cubed, z squared, and z, the largest that could divide all of those would be a z. So 3z is my greatest common factor, and I'm going to go ahead and divide to get the polynomial in here. So 6z cubed divided by 3z. First, 6 divided by 3 is 2, and z cubed divided by z is z squared, plus my 3z squared divided by 3z. I have a 3 divided by 3 is 1, and z squared divided by z is 1z, plus 9z divided by 3z. We have 9 divided by 3 is 3, and z divided by z cancels completely. So we think that those are the factors, but we're going to come over here and check to make sure. Remember to check, we simply multiply the factors that we got together. So we have 3z times 2z squared is 6z cubed. 3z times z is 3z squared. And 3z times 3 is a 9z. So I did come up with the same starting polynomial. So this is the factorization of that polynomial. What's the greatest common factor here? Well, we have a 5 and a 10 for our coefficients. The largest number that would divide both of those is 5. We have an x squared y to the fourth and an x cubed y cubed. What's the largest of the x's that would divide both of those? An x squared. And y to the fourth, y cubed. What's the largest y that would divide both of those? A y cubed. So 5x squared y cubed is my greatest common factor, and I need to decide what that binomial was that gives us this when we multiply by that. So 5 divided by 5 is 1, x squared divided by x squared is 1, and y to the fourth divided by y cubed is y, plus 10 divided by 5 is 2, x cubed divided by x squared is x, and y cubed divided by y cubed is simply 1. So let's go ahead and check this by multiplying 5x squared y cubed through y plus 2x. I have a 5 times 1 is 5, x squared, y cubed times y is y to the fourth, plus 5 times 2 is 10, x squared times x is x cubed, and my y cubed. And I do come up with the same thing I started with, so this must be the correct factorization of that polynomial. What's the greatest common factor here? It's a little tricky to see because we have a binomial sitting there. But think about if we replace that binomial with something like a large b. So xb minus 2b. And what's the greatest common factor here? It would be a b, and I would be left with x minus 2. So it's the same thing with this polynomial, except that the binomial is our b. So what we'll do is recognize that x plus 1 is the greatest common factor, just like the b is the greatest common factor. Let me highlight these to let you see. This x plus 1 is the same as this b, and this x plus 1 is the same as this b. So I have an x and an x, a minus 2 and a minus 2. I'm factoring out b, and I'm left with x minus 2. Now if I multiply this back out, of course I would get the same thing I started with. So here we're going to have the greatest common factor of x plus 1. It's a binomial greatest common factor. Now what did I multiply when I factor out here? I have x times x plus 1 divided by x plus 1 is x, and a minus 2 times x plus 1 divided by x plus 1 is 2. So it's the same thing that we had before. The x plus 1 is our greatest common factor, and we're left with x minus 2. Now it's interesting when we check this, what happens. We have an x plus 1 and an x minus 2. If I multiply that out, I'll have x plus 1 times x, or if you wanted to, we could go ahead and FOIL. X times x is x squared. X times negative 2 is negative 2x. 1 times x is a plus 1x. 1 times negative 2 is negative 2. And I have an x squared minus x minus 2. Now this does not match what we have here, but this is a polynomial that isn't completely multiplied out. So let's take that x plus 1 and minus 2 x plus 1 and go ahead and multiply everything out. We have an x times x is x squared, and x times 1 is x, minus 2 times x is 2x, and minus 2 times 1 is a minus 2. This gives me an x squared minus x minus 2. And they are indeed the same thing. So this is definitely the correct factorization of that polynomial that looks a little funny right now. What is the greatest common factor with this polynomial? Again, we have a case where we have the binomial greatest common factor. You can think of it as 4x cubed b minus 2x b. If we had a polynomial like this, the greatest common factor we would take out, it would be a b. And we'd have a 4x cubed minus 2x. Yet, when we're looking at this binomial, we also have a greatest common factor of 2x. So we'd have a b times a 2x times a 2x squared minus 1. So let's apply this over here. I have a greatest common factor of x minus 5. So I'm going to take out an x minus 5, and I'm going to be left with, let's put that in parentheses, I'm left with a 4x cubed minus 2x. Yet this has a greatest common factor of 2x, so our complete greatest common factor is a 2x x minus 5. So let's go ahead and put our x minus 5 there, take out the rest of the greatest common factor, and we're left with 2x squared minus 1. You may want to rewrite this as a 2x x minus 5, 2x squared minus 1. Either way is a correct answer. It just seems that this looks a little more aesthetically pleasing. We don't have as many parentheses with everything. So the next type of factoring we're doing is factoring by grouping, and the last couple of problems that we did were actually factoring by grouping that were halfway finished for you. Let's look at this example, x cubed plus 2x squared plus 3x plus 6. What we do is group the first two terms together and the last two terms together. Don't use parentheses because most likely if you use parentheses you're going to use them wrong. So we want to make sure that we're just underlining. What we want to do is take out the greatest common factor of the first two terms. And the greatest common factor there would be an x squared. And we're left with an x plus 2. Then we'll take out the greatest common factor here. Of course, we need to follow down, put that plus here. We're taking out a greatest common factor of 3. So the greatest common factor 3 is going to go there. And what would we be left with? An x plus 2. Now we see we have this term, and we have a binomial greatest common factor that can come out of x plus 2, and we're left with x squared plus 3. Remember that this is very similar to factoring x squared b plus 3b. We factor out the b, and we're left with x squared plus 3. It's just that the b over here is that binomial x plus 2. If you'd like, we can check this. We simply FOIL the x plus 2 and the x squared plus 3. That gives me x times x squared is x cubed. X times 3 is a 3x. 2 times x squared is 2x squared. And 2 times 3 is 6. If we put this in descending order, it's x cubed plus 2x squared plus 3x plus 6, which is exactly what we started with, so we know for sure that this is the factorization of that polynomial. So let's factor these polynomials. 15z cubed minus 5z squared plus 6z minus 2. First, let's group the first two terms and the last two terms. What's the greatest common factor of the first two? That would be a 5z squared, and that leaves us with a 3z. Carry down the minus, and 5z squared divided by 5z squared is 1. It's very important that we write that 1. Otherwise, when we multiply back, we would only have a 15z cubed, and we wouldn't have the minus 5z squared. Now, out of this, we're taking out a positive 2, and I'm left with 3z minus 1. Now, those factors are the same, so we can go ahead and out of this term and this term take out the 3z minus 1 greatest common factor, and we'll be left with a 5z squared plus 2. Again, we can check this. 3z minus 1 times 5z squared plus 2. I have a 3z times 5z squared is 15z cubed. 3z times 2 is a plus 6z. Negative 1 times 5z squared is a minus 5z squared. And a negative 1 times 2 is negative 2. Of course, if we would want to put this into descending order, make sure that you carry the signs with the correct terms. Then you'll see that we have the exact same polynomial that we started with. So that was the correct factorization. Let's go ahead and factor this with grouping. The way we know that we're going to factor with grouping is that it has 4 terms. The greatest common factor for the first two terms is a 3r squared. and I'm left with a 3r plus 2. Now this is a little different here because my second set is leading with a negative. So if that leads with a negative, we want to take out a negative greatest common factor. So a negative, the greatest common factor is 2. We'll be taking out a negative 2. And be careful with the signs here. I have a negative 6r being divided by negative 2, which is a positive 3r. I have a negative 4 divided by negative 2 is a positive 2. Now I have this term, and I see that I have that greatest common factor of 3r plus 2. And that leaves me with a 3r squared minus 2. If you'd like, we can check it, or you can go ahead and check it just by visually multiplying. 3r times 3r squared is 9r cubed. A 3r times negative 2 is a negative 6r. A 2 times 3r squared is 6r squared. And a 2 times negative 2 is negative 4. Let's go ahead and try to factor this one by grouping. We have, for the first two, a z squared, and we're left with a z minus 4. We're starting out here with a negative, so when we lead with a negative, we'll take out a negative greatest common factor, and the greatest common factor of 7z and 28 is 7, which leaves us with a negative 7z divided by negative 7 is a positive z, and a positive 28 divided by negative 7 is negative 4. It's very important that we do that we're very careful with the signs, because these factors have to be the same for us to be able to continue factoring by grouping. So I have a z minus 4 greatest common factor, and I'm left with a z squared minus 7. Again, we can go ahead and multiply z cubed, negative 7z, negative 4z squared, and a positive 28. Here we have 4 terms, and we're going to factor by grouping, but the first thing that we need to notice is that we have a greatest common factor out of all the terms. We did not have that before. In this one, there was no factor that they all had in common, and this one, there was no factor that they all had in common. But here, we're going to have to factor out the GCF of the entire polynomial. That will make the rest of the process a lot smoother for us. So looking at the coefficients, 4, 2, 12, and 6, they all have a 2 in common. Looking at x to the 5th, x to the 4th, x cubed, and x squared, they all have at least x squared. When I do that, I'd be left with a 2x cubed plus x squared minus 6x minus 3. You'll notice that I've used square brackets. That's because we're going to have to keep this greatest common factor in front, and we'll factor the inside as the factor by grouping. So it's important to keep the square brackets, so at the whole time we're doing this, we have this multiplying everything in the square brackets. So again, I'm going to find the greatest common factor of the first two, and that's x squared. I'm left with 2x plus 1. And grouping the last two, I start with the negative, so I know I'm taking out a negative greatest common factor. And the greatest common factor between 6x and negative 3 is going to be a 3. So again, I'm taking out a negative 3. Negative 6x divided by negative 3 is a positive 2x. And negative 3 divided by negative 3 is positive 1. So this is looking good. I now have this term, and the factor I want to take out is 2x plus 1. So I have a 2x squared and a 2x plus 1, and an x squared minus 3 is left. And really everything is being multiplied here. This multiplies this, multiplies this. So at this time there's no need for us to have those square brackets, and I can move my 2x squared a little closer. And that's my factorization. If you want to check this, what we would want to do is multiply two of the things together, and then after we simplify, multiply in the third. I'm going to go ahead and multiply my two binomials together. So this is a 2x squared times whatever I have this to multiply as. To be a 2x times x squared is 2x cubed. 2x times negative 3 is negative 6x. 1 times x squared is x squared. And 1 times negative 3 is negative 3. Now I don't have any like terms to put together, but I can put those in descending order. So it's 2x cubed plus x squared minus 6x minus 3. Now I need to multiply the 2x squared through all four terms of that polynomial. So 2 times 2 is 4, x to the 2 and 3 is 5, plus 2, x squared times x squared is x to the 4th, minus 2 times 6 is 12, x to the 2 and 1 is 3, minus 2 times 3 is 6, and my x squared. And I did come up with the same terms that I had in my original polynomial, so this is definitely the correct factorization. You might want to go ahead and practice your factoring skills so far. If you'd like, you can pause the video now, take a piece of paper and try and factor these polynomials. When you're finished, you can unpause the videos and I'll have the answers to the right. So here you have the factorization of your polynomials. How did you do? If you have any questions on this, you can email me and I can help you through factoring any of these or explain why you stop at a certain place when you're factoring. Go ahead and try your homework and let me know if you have any additional questions.